Get started, everybody, and just a few announcements before I introduce our speakers today. And even before that, I just want to thank all of you who have been participating in our graduate environmental engineering series. Whether it's your first time joining us today or whether you've been consistently logging in, I really think it's wonderful that we have a community of faculty and graduate students and even members of our larger community who value this seminar series and the opportunity to get broader education, broader awareness of the field of environmental engineering. So thank you for being part of the seminar series. Again, just a couple of general announcements. This is our last environmental engineering seminar. If you wish to have documentation of your continuing education, please contact Dr. Eric Seagren and he will provide that documentation to you. Also, a reminder that we have all of our participants on mute and prevent sharing of video streams. So if you have questions, please feel free to type them in the chat, and you can also raise your hand and we'll reserve the Q&A for after our speakers present. We do have two speakers today, and I think it's really great to end the semester with some presentations by two of our own graduate students. We are lucky to have such great dedicated students in our program. And so today we'll be hearing from Amanda Singer and Miraj Kayastha. And I'll go ahead and introduce them. We're going to have Amanda Singer speak first. Amanda graduated from Michigan Tech in the spring of 2019 with a BS in environmental engineering and returned to Michigan Tech the following fall to pursue graduate studies. She worked with her advisors, Dr. Judith Perlinger and Dr. Michelle Jarvie-Eggert, and her research is focused on engineering education topics, and she has a special interest in environmental engineering education, service learning projects, and student persistence and identity in engineering. After graduation, Amanda will be moving to Columbus, Ohio to begin her work on her PhD in engineering education at The Ohio State University. There she will be working with the research on identity and motivation in engineering, or RIME collaborative, studying the intersection of motivation and identity in engineering and its links to fostering engineering student success. Miraj graduated from Kathmandu University in Nepal in 2018 with a Bachelor's of Engineering in Civil Engineering. He joined Michigan Tech in fall 2019 to pursue an MS in Civil Engineering. He works with his advisor, Dr. Pengfei Xu, and focuses on modeling the impact of climate change on the regional climate of the Great Lakes. He is on course to graduate this semester with the MS degree and continue at Michigan Tech as a PhD student from summer 2021. So again, this is wonderful to have not only successful master's degree students, but ones who are going on to pursue the PhD. And with that, I'm going to turn it over to Amanda Singer.
Perfect. Thank you, Dr. Becker, for that introduction. Today, I'm here to present on some of my graduate research, which is focused in understanding the learning outcomes and benefits of implementing service learning opportunities into engineering courses. So more specifically, we're going to be looking at an application here at Michigan Tech in which the EWB, or Engineers Without Borders Design Challenge, was integrated into one section of 1102, or ENG 1102, which is one of the introductory courses all engineers must take here. So before I talk about my research methods and some of the results I obtained, I really would like to provide a little bit of context into what service learning is, what some of its benefits are, and how it connects to the EWB Design Challenge. Service learning itself is a teaching and learning strategy or an educational approach that really focuses on integrating meaningful service projects within an existing course structure. So the goal of service learning is to introduce students to real world projects where they have the opportunity to work alongside other students and community partners. There is an extensive literature section on the impacts and the integration of service learning into different courses. Specifically, Dr. Janet Eiler and her colleagues conducted a literature review back in 2001, which really sought to define and summarize the impacts not only that students were seeing from participating in service learning, but also how faculty, university, and community partners were benefiting. As can be seen in this figure, some of these benefits are summarized here. From the student perspective, service learning has been linked to positive personal, social, and learning outcomes with a distinct connection to increasing self-efficacy and student persistence. Looking at these benefits, it has become very popular in engineering education, the implementation of service learning, and continues to grow each year. So how does this connect to the EWB Design Challenge? The EWB Design Challenge is an adapted form of service learning. Each year, Engineers Without Borders Australia invites first-year engineering students to participate in their design challenge. They provide these students with project briefs and technical resources to aid them. The project brief outlines the communities that they'll be working with, as well as some of the challenges that they are facing. Overall, EWB aims to accomplish two goals with this design challenge. Specifically, they look to develop holistic skill sets in their students, which prepare them to work on the global stage when they graduate. In addition to this, they look to evolve traditional engineering education by introducing students to topics in sustainable design and human-centered design. Again, this is a form of adapted service learning. Students do not have the opportunity to directly interact with the community that they're working with. Instead, EWB provides one of their members as a point of contact between the students and the community. Unfortunately, with the size of this project, and the number of people involved, it really wouldn't be useful to have community partners talking and interacting with over 10,000 students each year. So in order to accomplish really aid in that and make sure that all students are receiving the information they need for their projects, they also supply webinars for students to participate in and discussion boards to ask questions. So the EWB design project has been extensively integrated into universities in Australia and in New Zealand, and they've had real great success with it. However, there really hasn't been much participation from universities here in the US. In fact, before integrating it here at Michigan Tech in the spring of 2020, Colorado State was the only college here who had participated. So they integrated this project into their first year courses, really looking to provide students with the opportunity to participate in this project. Being that they were the only school in the US to be participating in it, faculty members were really interested to see what the student learning outcomes would be and how it would affect student understanding of different engineering issues and how it would affect their development of engineering skills. As a result of this, they developed a post-course survey, which they administered to their students to really measure these different metrics. In analysis, they found that there was overwhelming support for this project, with 81% of their students indicating that they should keep it as a part of the course curriculum. In addition to some of these questions, students were also asked to complete Likert scale questions and to indicate if different aspects of the project had positively influenced, negatively influenced, or not influenced their understanding of different issues and the development of their skills. These results are presented in Figure 5 and Figure 7 on the right-hand side of this slide. It is important to note that The numbers you are seeing are reported as number of student respondents and not percent. So from this, again, we don't have the exact numbers, but based on the images, we can see that overwhelmingly students indicate that this project has a positive influence on their understanding of the role of an engineer, both within society and globally. It's also helped them in understanding how culture affects engineering decisions and the importance of defining a problem in the context of a community. Switching gears and looking at the results from the development of their personal skills, again, overwhelmingly positive influence of the project, with many students with over 50% or 50 respondents indicating a positive influence in each of these categories. Ultimately, the faculty at Colorado State had several recommendations, the first of which being that more universities in the US should participate. In addition to that, they suggest that participants, especially faculty and universities, should collaborate with others who have participated in the project to really provide insight on how to better integrate it into courses here. So recognizing the extensive literature background of service learning and the impacts that the Colorado State students and faculty are seeing, this challenge was integrated into the Michigan Tech first year engineering curriculum in the spring of 2020. During its pilot year, it was integrated into one section of ENG 1102. In this section, these students were working on the EWB Water Aid Design Challenge from the year 2019, which focused on working with communities in the Manifahi district of Timor-Leste. Students in this project were tasked with selecting a project within one of the priority areas that EWB identified, which included areas related to design of transport and storage for household water, design of gray water reuse systems and sanitation systems, as well as other projects. So looking at some of the impacts that students were seeing at Colorado State and acknowledging the extensive literature background on service learning, I was really interested to see how Michigan Tech students were going to fare in this challenge and what they were going to learn from it. Knowing that, I developed several research questions which looked specifically at how this design challenge was going to affect their perception of the role of an engineer, both on projects and within society, as well as what students would perceive as the most important skills or knowledge that they gained. So in order to collect this data, an end of semester project reflection survey was developed. It was in part adapted from the Colorado State survey to include their Likert scale and yes/no questions. But in order to provide further context to the results of these questions, several short answer, open-ended reflection style essays were also added, where students were asked to reflect on how their views on the roles of engineering had changed and what they identified as the most important things being learned. So to analyze the student results, several methods were used. Unfortunately, we did not have the full data set from Colorado State, so we could not conduct statistical analysis and t-tests between the two data sets. So the results you will see presented in this presentation are reported as percentages and counts. Ultimately, hopefully in the future, we will be able to obtain that data set and provide further insight. However, we were able to fully analyze the short answer questions. We use Convergent coding methods, which is a multi-step process for qualitative data. In this process, you start out by working with your research group and individually reading through student responses, highlighting different themes or emerging comments that you're seeing within it. From there, you meet with your research group, discuss those themes, and ultimately develop a code book, which is then used for multi-cycle coding until convergence between researcher answers is reached. So again, for this data set, me and my research group, we conducted dual cycle coding, and at the end of the second cycle, we were all in agreement on how each of the student responses should be coded. At a broad scale, the survey presented us with overwhelmingly positive feedback, even more so than that of Colorado State. Students at Michigan Tech indicated support in keeping it as a part of the engineering curriculum, with 93% in support of that. Additionally, over half the students who completed the survey indicated that they were interested in joining a local chapter of EWB, and 3/4 discuss seeking international work in the field of engineering after graduation. Looking more specifically at the Likert style questions, students were initially, in the first Likert scale question, students were initially asked how the EWB challenge had affected their understanding of different contemporary engineering issues. So from these results, again, we can see overwhelmingly that students reflected in a positive light towards the project and its impact on these different issues. Specifically, Michigan Tech students highlight that the project impacted their understanding of the role of an engineer, both within society and globally, as well as connecting the design process to understanding the needs of the community. The second Likert scale question, similar to the Colorado State, focused on the skills that the students developed during this course. Again, we see student reflections in a very positive light towards the project and in impacting these. We do have several students who did indicate a negative impact, and it is important to note that this project was first introduced during the spring of 2020 when COVID first hit the United States. And in reflection of that, some of these comments related to working with others and understanding the design process may be affected by that. So now that we've looked at the Michigan Tech results, we can compare it to those of Colorado State. Now, again, we didn't have the full Colorado State data set. If we did, we could have performed further statistical analysis on the Likert style questions. However, from the graphs, we can see that overall we're seeing a similar trend between both institutions. Similarly, we are seeing positive student reactions to the program with increased interest in EWB participation and global engineering opportunities, as well as students at both institutions indicating that this project or this design challenge should be kept a part of the course. So in order to provide some further context and some further insight into these yes, no, and Likert scale questions, students were also asked to answer these short answer essay-like prompts. And from these, again, the qualitative coding was used to analyze student responses. Within student responses, several different themes emerged, specifically the connection between contemporary engineering and traditional engineering education, the design thinking model, communication, and project relevance. The most prevalent within EWB student responses in relation to their views on the role of an engineer was that of contemporary engineering education, which really connects the goals and the teachings of the EWB project of humanitarian engineering, global scale work, real world work, and the broadness of engineering to what they perceive as the role of an engineer. In addition to this, another prevalent theme within student responses was that of project relevance. And this code included the sub-theme of reinforcing. And what that represents is students who in their response didn't necessarily state that their view on the role of engineering had changed, but that this project had reinforced what they had thought and what they see themselves as in the future as an engineer. On this slide, I have provided a few of the student quotes that were collected within the survey. These again reflect on the different themes that were identified within student responses. And here we can see a variety of different things. One student writes, I think this class is structured in a way that allows students to get a better idea of how projects may be structured in industry. This really allowed me to understand what the roles of different engineers could be in the future, and it helped drive home the idea that they will play a part in the process from creating a design to implementing it. Other student quotes in this section of the survey also connected the themes of sustainable engineering and human-centered design and how that would connect into their role or what they view as their role as an engineer in the future. So moving on to the second short answer question, this one focused on what students perceived as the most valuable things that they learned throughout this challenge and within the course. Here, there's a little bit more of a distribution between the student responses. We do see that overarchingly, the most prevalent themes are that of engineering skills, the design thinking model again, time management, communication, personality traits of a good engineer, and educational relevance. So students who completed the EWB project, while they do reflect on the learnings from EWB of sustainability and human-centered design, they also reflect on what we consider more traditional engineering skills. So problem solving, technical skills, project management, but their responses do it in the context of the EWB challenge and the problems they were facing. Additionally, it's important to note the second most prevalent theme of design thinking. This structure was introduced to students during the course as a part of the project. And student reflections here, while it doesn't distinctly outline, student quotes and student responses highlight the importance of the empathize role, which really focuses on meeting the needs of the client and considering the culture and community input. So from this, we can see that students really value overall the different skills that they are obtaining through working this challenge, as well as understanding design thinking and its different components. Again, here's a sample of a couple quotes provided by students. We can see that the different students provide different insights. One student reflects on the importance of team collaboration in achieving the end goal, while the other talks about the process of design and ensuring that the product can be at its greatest potential. Ultimately, again, we are seeing some very interesting themes within student responses. However, we wanted to put that in the context and compare it to other project-based classes. This is an essential component of our engineering curriculum here, especially in the first year program, where students in the ENG 1102 course complete a semester project, regardless of what section they are in. The main differences that I want to draw attention to here is that when we compare the ranking of the different themes between the EWB project and an adaptive bike project for disabled athletes, we see that students within the EWB section, they reflect on this idea of contemporary engineering, the broadness of engineering and its connection to human-centered design and research. Whereas the adaptive bike project, the theme of contemporary engineering is much, much lower on this ranking. Their top ranking was in project relevance and how it reinforced their idea of what an engineer is. When we compare student learning outcomes from both projects, we see very similar results. In fact, the rankings are exactly similar. However, there are differences in the individual or subcodes underneath it. EWB students, within the design thinking code, EWB students again reflect on the importance of the empathize phase in design thinking, which really focuses on meeting the needs of the customer and really putting themselves and understanding the culture they'll be working in. In comparison, adaptive bike responses under the design thinking category were more focused on the overall design process and not necessarily the individual steps. So So looking ahead, again, this was the first, this pilot course was first introduced in 2020. Currently, there is another section of the EWB challenge being taught this semester in the 1102 course. So we are looking to continue collecting information and looking at these student outcomes through the life of that project here at Michigan Tech. We also have further interest in integrating the EWB challenge into the course content further. So introducing pre and post course surveys to evaluate any changes in learning and to really look at how student perceptions change throughout the course of the semester with the project. In addition to that, there are further connections that we would like to explore. Specifically, how do the outcomes of this service learning compare to other project-based courses? So really delving further into the differences between that and trying to tease out exactly what service learning, trying to tease out exactly what the learning outcomes are from service learning in the context of MTU courses. Additionally, we would like to see if this has any connections to persistence in engineering, so potentially running more longitudinal studies to see how it affects student retention, and possibly looking at how introduction to these design challenges, service learning challenges impact interest in civil and environmental engineering. In conclusion, the EWB Design Challenge was fully integrated into one of our first-year engineering courses here at Michigan Tech. Our first round of surveys presented overwhelmingly positive feedback, especially when we compare them to CSU results or Colorado State. The results from the survey also show student recognition of the themes related to contemporary engineering, which are the main goals of the EWB challenge. These themes and recognitions of them are further highlighted when we compare them against students who are participating in different traditional project-based classes. And we would like to explore those connections in the future.
Great, thank you, Amanda. It was really interesting, and I think at this point we'll quickly have Miraj begin sharing his screen, so that hopefully we have some time for questions at the end for both of you. And Miraj, just a reminder that you can feel free to share your video as well.
Okay. Okay, hello everyone. My study focuses on predicting the impacts of climate change on the water levels of the Great Lakes. And first, I would like to acknowledge the Michigan Department of Environment, Great Lakes and Energy, NOAA, and the U.S. Army Corps of Engineers for their invaluable support during my work. So I'll start off by introducing the water levels of the Great Lakes and then talk about how they can be predicted. Then I'll describe the models used in this study, followed by the water level predictions. The Great Lakes of North America consists of Lake Superior, Lake Michigan-Huron, Lake Erie, and Lake Ontario. Collectively, they contain 84% of North America's surface freshwater and 21% of the world's surface freshwater. And the US coastline along the Great Lakes is actually longer than the coastline along the Atlantic Ocean, the Pacific Ocean, and the Gulf of Mexico. And the Great Lakes Basin is home to more than 30 million people. And in terms of economy, Great Lakes supports 1.5 billion jobs and $62 billion in wages per year. So we can see that the Great Lakes are massive and important, but why focus specifically on water level prediction? One reason would be to predict possible damages on shoreline properties due to flooding. But besides flooding, water level also affects the shipping industry, hydropower generation, wetland ecosystems, fisheries, and shoreline erosion. As an example, studies have estimated that for every inch of water level drop, $11,000 to $22,000 could be lost in daily shipping profits per ship. Another reason to predict water levels are their recent significant changes. For example, the August and September water levels for Lake Superior were at their lowest in 2007, but at their highest in 2019. And this was due to a record-setting rise in water level during 2013-14. Hence, water level prediction has become a crucial topic of research in recent times. So to predict water levels, the water budget component of the lake that drives the water level changes must first be identified. All the water budget components are included in the following water budget equation, which basically tells us that the change in water level is the water coming into the lake minus water going out of the lake. The overlake precipitation minus lake evaporation plus basin runoff term can be collectively known as the net basin supply. So the water budget equation is simplified to this. Now, all the water budget components except the net basin supply are usually assumed to be either extremely small or have no direct effect on the water level changes. So net basin supply is regarded as the only driver behind water level changes in the Great Lakes. So to predict water level changes, we first have to predict the net basin supply. Now, the question is, how is net basin supply predicted? The most common tools to predict the net basin supply are GCMs and RCMs. GCM, which stands for General Circulation Model, is a numerical model that simulates the response of global climate to increasing greenhouse gas emissions. And they have a very coarse resolution, spatial coarse resolution, which makes them incapable of simulating small-scale processes and features. And it is important to understand that GCMs from different institutions predict different future climates, because each of them can have different model configuration. Hence, climate change studies opt to use an ensemble of GCMs in their studies to capture the range of possible future climates. RCMs, on the other hand, stands for Regional Climate Model and are a high-resolution model that derives its boundary conditions from GCM simulations to spatially and temporally refine the GCM's large-scale information. This process of refinement is known as dynamical downscaling, and one of the advantages of using RCMs is the ability to simulate small-scale processes, which are very important in the Great Lakes. And here is a simple schematic of dynamical downscaling for a region around the Mediterranean Sea. This shows the refinement of topography obtained from the use of RCM. We can see that the GCM covers the whole Earth in a coarse resolution, but the RCM, by focusing on a small region, produces a much more refined and detailed elevation map with information that was previously absent in GCM's results. Now, recent studies have predicted NBS and water levels used dynamical downscalings, but their RCMs were coupled to only 1D lake models. And a 3D lake model is required to properly model the Great Lakes. 3D models can better resolve horizontal and vertical mixing within the lakes and thus simulate the thermal structure and ice formation of the lakes better than 1D lake models. So in this study, we used a 3D regional climate modeling system, along with the large basin runoff model and the coordinated Great Lakes regulation and routing model to predict the future net basin supply and water level changes. The RCM used in this study is called GLAM, and it was used to predict overlake precipitation and lake evaporation. The large basin runoff model was used to predict the basin runoff, and the coordinated Great Lakes regulation and routing model was used to predict the future lake levels. And now I'll introduce the three models used in this study, starting with GLAM. GLAM is a two-way coupled 3D regional climate modeling system that includes a hydrodynamic 3D lake and ice model. It's made up of the REG CM4 RCM that is fully coupled to a 3D hydrodynamic model, which is based on FECOM. And in this study, we used two domains to run GLAM, shown by the magenta boxes in the two right images. They are the US domain and the Great Lakes domain. And GLAM also has a significantly higher horizontal spatial resolution than GCMs, namely 18 kilometers for the domain and 1 to 4 kilometers for the lakes. The second model is the large basin runoff model. It's a physically based conceptual model developed by GLERL that uses a tank cascade model to simulate basin runoff. Its primary inputs are daily precipitation and daily minimum and maximum air temperatures over the basins. It's a relatively simple model that makes multiple simplifications. For example, it ignores the water stored in small surface depressions. It ignores evaporation from and condensation to snowpack. And it also assumes that snowmelt only occurs during above zero air temperatures. The final model is the regulation and routing model. This model calculates the water level and the flows in the connecting channels of the Great Lakes. And unfortunately, during the time of this study, the model could not simulate Lake Ontario's water levels as the module responsible for it was non-functional. Its primary inputs are the net basin supply of each of the lakes. And since it's only a routing model, it does not consider any hydrodynamic anomalies such as ice jams that can occur in the river channels. Now on to the model settings for the study. So the baseline period for this study was 2000 to 2019. So the changes predicted in this study will be with respect to the conditions of this time period. And we predicted the changes for two future time periods, 2030 to 2049, which is the mid 21st century, and 2080 to 2099, which is the late 21st century. And the emission scenario we chose was RCP 8.5. RCP 8.5 corresponds to the pathway with the highest future greenhouse gas emissions. So we chose the worst possible future for our prediction. And GLUM was used to dynamically downscale 3 GCMs, namely GISS, IPSL, and MPI. These 3 GCMs were selected out of 19 possible CMIP5 GCMs based on their high reliability factor under the REA ensembling method. And in total for this study, 4 dynamical downscalings were considered. The first 3 downscaling cases are the 3 GCMs, GISS, IPSL, and MPI downscaled using GLUM, whose domain is the Great Lakes region. And the last downscaling case is the downscaling of IPSL using GLUM with a domain of US. So for each future time period and lake, we have 4 water level predictions. And here I would like to mention that the development of GLUM and the subsequent dynamical downscaling cases were performed by Dr. Pengfei Xu, Dr. Xinyu Yi, and Chenfu Huang. The whole process took them around 2 years and were performed using Michigan Tech's Superior HPC. So I would like to thank them, as without their work, my work would not have been possible. And finally, before moving on to the predictions from this study, I would like to show the modeling framework of this study to make the methodology a bit more clear. So first, we dynamically downscaled 3 GCMs using GLUM. Then from GLUM, we got the changes in overland air temperature and overland precipitation. These were used to create the inputs for LBRM, from which we got the changes in basin runoff. Along with this, we got the changes in overlake precipitation and lake evaporation directly from GLUM. So we combined these 3 changes to get the changes in net basin supply, which we combined with the observed net basin supply to get our future net basin supply. Finally, we fed this future net basin supply into the regulation and routing model to get our future water levels. So moving on to the predictions from this study. First, we look at our predicted changes in the first component of net basin supply, the overlake precipitation. These are the predicted changes in annual overlake precipitation. For each lake, we show the predictions from each downscaling case, as well as the average of them as the ensemble average. The red bars are the changes by the late 21st century, and the blue bars are the changes by the mid 21st century. And we see that the predictions are very different from each other. And this is just one of the examples of the uncertainty in future climate modeling, and one of the reasons as to why we look at more than one downscaling cases in our predictions. And if we look at the plots, IPSL case is the only one that predicted decreases into the future. And if we look at the ensemble average, over lake precipitation is likely to increase into the future. And these are our predicted changes for each month. And here I show the changes for Superior and Lake Michigan Huron only, but the conclusions apply to the other lakes as well. And here each colored triangle represents each downscaling case, and the black line represents the ensemble average of them. The trend of the ensemble average is very similar to what previous studies predicted, but unlike previous studies, our results show small decreases in the early months and increases in the summer months. Now we move on to the next component of net basin supply, lake evaporation. And we can see that for Lake Superior, lake evaporation is predicted to decrease in the future. But for the other lakes, it's predicted to increase. And this decrease in future evaporation agrees with the current state of evaporation in the Great Lakes. In recent years, evaporation in the Great Lakes has decreased, and this was one of the reasons for the recent water level rise in the Great Lakes. And in terms of monthly changes, we predicted a decrease in the first 3 months, followed by a slight increase in the summer. Now, in case of Lake Superior, evaporation is predicted to decrease at the end of the year as well. But previous studies predicted that evaporation would increase in almost all the months. So we looked at why evaporation decreases in the early months, even though the winter ice cover in the future decreases, because logically less ice cover would mean more evaporation. So to answer this, we looked at two factors that affect evaporation: wind speed and specific humidity. These two variables are related to evaporation by the following formula. So we looked at what happens to these two variables in the future to explain our predicted decrease in evaporation. So here are the predicted changes in monthly wind speed, and we can see that it decreases in almost all the months. And if we look at the changes in the difference between the saturated and actual specific humidity, which is the actual term in the evaporation formula, we can see that it is predicted to decrease in the early months, but increase in the later months, except for, again, Lake Superior, where it's predicted to decrease at the end of the year as well. So the combined changes in these two variables are one possible explanation for our predicted decrease in evaporation. Now on to the last component of net basin supply, basin runoff. Based on the ensemble average, basin runoff is likely to increase. And just like in overlake precipitation, IPSL cases predicted decreases in basin runoff. And looking at our ensemble average of the predicted monthly changes, we see a clear trend. There's an increase in the winter basin runoff, followed by a drop in late spring. This trend is similar to what previous studies predicted. And the increase in winter basin runoff is likely due to increased and early snowmelt. And the drop is likely due to the decreased snowpack which follows the early melting. And now we get to the predicted changes in net basin supply. And based on the ensemble average, once again, NBS is likely to increase into the future, which means that lake levels are likely to increase as well. And as expected, the IPSL case predicts some decreases in net basin supply as well. But we can see that most of the other cases predict increases. And looking at our monthly predicted changes, NBS is predicted to increase in almost all the months, but the least in the summer with possible decreases. And previous studies have predicted similar trends, but with decreases in the summer and early months. Now, our predicted increases in the summer for NBS is due to the smaller increases in evaporation. And finally, we end up with our water level predictions. Now, for water level predictions, we had to ignore the first 10 years of our time periods because we had to remove the effects of our assumed starting levels in our simulations. So these plots are the changes in average water levels for the remaining 10-year time periods. And based on the ensemble average, the water levels are likely to increase into the future. And we see that the lake levels in Superior is predicted to change the least, while the lake levels in Michigan Huron are predicted to change the most. The maximum increase for Superior is around 0.75 meters, and the maximum increase for Michigan Huron is around 2.4 meters. Now, our predicted increases are significantly larger than our predicted decreases. Furthermore, our predicted increases are significantly larger than what previous studies had predicted, because our predicted NBS was significantly larger. And here is a plot that shows the historical and the ensemble predicted average water level. The blue lines are the observed monthly lake levels from 1918 to 2019. The black line is the average for that whole period. The green lines at the end is the average for just the 2010 to 2019 period. The solid red line is the predicted average water level for the mid-21st century, and the dashed red line is the predicted average water level for the late 21st century. And we can see that our predicted average water level for the mid-21st century is within the natural range of water levels, whereas our prediction for the late 21st century is near the historical water level peaks. So this is the monthly climatology of our historical and predicted future monthly water level. The top row is for the mid-21st century, and the bottom row is for the late 21st century. And once again, the colored lines are for the 4 downscaling cases. The solid black line is the ensemble average, and the dotted black line is the historical water level. And based on our results, we see no discernible changes in the seasonality of water levels, except for a slight change in the peak month of Lake Superior. So in conclusion, here are the key takeaways from this study. So first, the annual evaporation in Lake Superior is likely to decrease, but it's likely to increase in the other lakes. And the decrease in evaporation is likely due to a decrease in wind speed and the difference between the saturated and actual specific humidity. And furthermore, the water levels are likely to increase in the future due to increases in net basin supply. And our predicted increases in water level is much higher than what previous studies had predicted. And once again, this was due to our significantly larger NBS increases. And that is it for my presentation. Thank you all for listening.
Great. That was another fascinating presentation. Are there questions for either Amanda or Miraj? Looks like we have well, a comment from Brian Rivers, Amanda, which I encourage you to read. And then a question from Dr. Noel Urban. Amanda, that sounds like a very valuable study. Was there any effort to contrast student learning outcomes other than through self-perception or self-assessment for students with service learning and those without, or between the 2 different service learning options? So that question will direct to Amanda. And if you have questions for either Amanda or Miraj, please do type them in the chat or raise your hand.
Okay, so in response to Dr. Urban's question, in terms of any efforts to contrast student learning outcomes other than assessment, no, there wasn't in this situation. That is something looking ahead that we would like to implement. However, the main, I guess, objective of what was trying to be done in this first year at Michigan Tech was really to try and validate or compare against what Colorado State was seeing, compare their methods, and then also to just see like what students thought about it. It would definitely be interesting, I think, to implement some other form of learning outcome assessment though. And then, or between the two different service learning options, no. So in both cases with the EWB project and the adaptive bike, both of those were self-assessments. But again, in the future, I think it would be very interesting to look into that.
Okay, and we thank you, Amanda. We have a question in the chat from, I think also from Dr. Urban. From Miraj, there's a paper reporting higher wind speeds over Lake Superior in recent years. That would seem to contradict your predictions. How do you explain the discrepancy? And I will just add that I also feel, my sense is anecdotally that it does feel like the wind speeds have been higher of late, but again, that's just an anecdotal observation. But Miraj, can you respond to that query?
Yes, so I think I've read the paper that Dr. Urban is referring to, and in that paper, they say that the wind speeds are increasing over the Lake Superior because lake surface temperature is rising faster than the overlying air temperature. So that was their reasoning as to why wind speeds were increasing over Lake Superior. But I did a small analysis based on our results, and our results showed that the lake surface temperature, the overlying air temperature was rising faster than the lake surface temperature. So it was exactly the opposite of what the paper presented. So that's why our results shows that the wind speeds are decreasing in the future.
Great. Are there other questions for Amanda or Miraj? Amanda, I have a comment or perhaps a question for you. It was interesting to me that the students, when asked about EWB, seemed to not think that they, I'm not sure how to exactly say that, but communication was consistently ranked very low among the different aspects of the project and or with the skills that they acquired, what they learned from their study. And to me, it seems like one of the most important aspects of service learning is the ability to communicate with communities. So I don't know if you can comment on that. Was that a surprising result to you, or is it because the students weren't directly engaged with specific communities that was not ranked higher communication?
Yeah, so I actually found that outcome very interesting as well. And I think it's kind of a twofold thing in terms of communication with the community that they were working with. I do think the fact that they weren't directly in contact with those community members did play a role. A lot of the EWB resources and supplemental materials is all available online they do present additional webinars and like articles throughout the course of the project, but most of that is available to students at the beginning of the project. And it's purposely left very open and broad so that students are tasked with, making the decisions themselves and trying to figure it out on their own. In addition to that, I think when we talk about communication in terms of like between the students or the student groups, the engineering fundamentals department here at Michigan Tech, specifically with the first year courses, they have what's called the LEAP program, and it really focuses on like peer interaction and peer communication. So this project was implemented into the second semester of the first year courses. So I think that some of the students may have already learned a lot of those communication skills in the first semester. So I think that may have also played a role. Or, their reflections were just more so focused on the actual impacts of the project, that maybe communication kind of lagged behind or wasn't as important to them. I don't know if that answers your question or.
Yeah, it really does. And it makes a lot of sense. So thank you for that. Are there any other questions for Miraj or Amanda? We maybe have time for one more. Oh, Dave Watkins. Let's see if we can.
I'm unmuted.
Mute.
Question for Amanda. Can you hear me?
Yep,
Yes, we
go
can.
ahead.
Oh, okay. Yeah, very interesting study. Can you clarify the two projects? Those were done in separate sections of
Yes.
1102? And
Yep.
so the students didn't really have a choice. I guess I'm wondering if you saw any results by major, like for instance, with the mechanical engineering students have been more interested in the bike project, and the environmental engineering students more interested in the EWB project. If you collected any data like that.
Yeah, so we did end up collecting data on like demographic data, so major, school year, that kind of thing. And the way that the program is structured, students in some cases know what projects they're going to have for the courses they sign up for, some they don't. Based on the student responses, there was a higher number of civil and environmental students in the EWB section as compared to the other project section, which was working on an adaptive bike project. And I'd have to look at the results, but I believe that the adaptive bike did have a higher number of mechanical students. So we didn't specifically look at that impact on the responses, but I think it would definitely be interesting to go back and look at that and see if there were any insights from that.
Mm-hmm. As far as promoting interest, that's great that students could have a choice between the two. So great, thank you.
Okay, thank you again, Amanda and Miraj, for finishing up our graduate environmental engineering seminar series on such a positive and interesting note. And thank you really to all of our seminar speakers, and again to all of you for participating. Have a great remainder for the semester. And of course, a wonderful summer as well. So thank you.